Hello everybody, this is going to be a quick video on tryLock. It's a non-blocking alternative to the lock method. And so let's talk about these two methods. If I just look in here, both of these methods are on the interface lock, which we've talked about has an implementing class called reentrant lock. And what we're going to do, let me just close these ones. We're going to look at these two different methods. One is called lock. It straight up acquires the lock. You call lock. When it returns, you've got it. And then tryLock returns right away, whether you can get it or not, and just lets you know via its true or false return type. And so, the Boolean is a return type. It tells you if it worked or not. So lock, like I said, acquires it. tryLock is like, well, is it available right now? If so, acquire it and return true. If it's not available right now, return immediately anyways and return false, and the person who called you can just go about and do something else. What I will say is whether you call lock or tryLock, lock is much more common, actually more common than an explicit lock is using the synchronized block. But it's much more common to call lock than tryLock, but it does have its uses, and we'll go over one today. No matter what, if you get a lock, make sure you always call unlock. Whether you call lock, always call unlock, or tryLock, if it succeeds, call unlock. If it fails, don't call unlock. You didn't get it, so don't do that. So let's talk about a quick example on how you might want to use tryLock. In this case, I've got a bank that's going to have this try again later policy on transaction processing. So I built some transactions. They are, deposit, withdrawal, and transfer between one account and another account. And so in this example, I create 1,000 accounts. I make a bunch of default ones. These accounts are all not thread safe. I've sort of explicitly make them so that they have shared mutable data, your balance, and there's a get and a set value. And we're going to make them thread safe in our transactions. I created a bunch of 100,000 random ones, and then I converted that list into a thread safe version of transactions because I'm going to be accessing it in this parallel program. So I just create a concurrent link queue out of that linked list, and now I can both first of all, be able to pull out transactions. So the idea here is I'm going to make a task for every single available processor. And then I'm just going to loop forever. And I'm just going to pull this concurrent link queue of transactions. Pull is like remove, except it doesn't throw an exception when it's empty. It returns null. So I'll be like, oh, was there a transaction there when I tried to remove one? If so, attempt to process it. That will tell us whether it worked or not. And then if it worked, awesome. I just processed that transaction. Let's move on to the next one. Otherwise, I'll try again later and just throw it at the end of the queue. That's what sort of offers a lot like add for a queue. And so let's look at how we're going to pull this off. And so if I run this program, the bank, this is the same program I just had. It's going to throw a not yet implement exception because I haven't implemented them yet. Again, to review, default account is not thread safe. It has this balance mutable data that is shared, and you can acquire it, set it, and get it. And so let's talk about this deposit transaction, which gets some account that's going to have one of these locks that I want to use to make things thread safe and some amount. And so the first thing I'm going to do is say, well, if that account, let's get the account's reentrant lock and call tryLock on it. If that returns true, that means you got it, right? And so no matter what, always do these things in try finally blocks because I've got a lock. I have to unlock it. So let's take that account's reentrant lock and unlock it when we're done, right? Because we always want to clean up after ourselves. And we're going to do something here, right? So I've got this account. Let's set its balance to be the account's balance. We're depositing, so plus the amount. Okay? And we're going to indicate that that worked, right? And so let me delete that line and return false otherwise. So I am attempting to process this transaction. It's a deposit. This account is not thread safe, so I'm going to be reading and writing to this. I'm in the midst of this bank program where everybody is taking these transactions, and another transaction might be operating on the same account, right? So I want to get the lock. If some other thread has this account's lock, then don't do anything. Return false, and this bank program can do whatever it wants, right? Like I attempted to process it, I failed it. This bank is going to choose to say, no problem, just throw it at the end of the queue. We'll deal with it later, right? Rather than block and wait for it to come available, I'll just deal with it later. And so back to here, this whole thing's going to, if it does work, we actually do it and return true. Otherwise, we return false. So just to come back here, what do you know? I'm just going to go over to withdrawal. It's going to be very, very similar. You can imagine this thing, a real bank would check the balance to make sure it didn't go negative and bill you. I'm just going to allow negative amounts just to make this simple. But sort of same process, like try to get the lock. Oh, it's available. Awesome. Let me do it. And we'll tell you it was successful. Otherwise, return false. No matter what, if I got it, unlock it. And this for the try finally handles exceptions and returning true early, which is very nice. The really interesting code comes here in transfer, right? Well, maybe not super interesting, but a little more interesting. So in this case, I have two accounts that are going to be operating here. I'm going to be sending some amount of money from the sender to recipient. I need both of those locks in order to proceed. So let's say sender, and nicely tryLock will allow us to avoid deadlock, which is nice. Let's get the sender's reentrant lock. Did that work? Awesome. Always try finally, right? Because I got a lock. Always make sure we unlock. If you ever get one, we're going to check the recipient. No matter what, I got this lock. I got to clean up after myself. So that worked. So let's do recipient dot reentrant dot try to lock that one. Okay, that worked, right? If that worked, let's we need to do try finally again, right? Because no matter what happens, I got this lock. I better unlock it. I'm going to get that reentrant lock and unlock it. So now, if I get to this point right here, that means I got both of them, right? Both of them are available. No problem. Let's actually do this. So what I'm going to do is I'm going to take the sender and set its balance to be the sender's balance minus the amount. And I'm going to, let's see if we can duplicate that line and just say the recipient. Let's grab the recipient's balance plus that amount. And again, a real bank would check to make sure you had the money, issue all sorts of fines. We were just going to ignore that for right now and return true that it worked. And otherwise, I come down all the way down here, and no matter what, I'm going to return false. So if I didn't get both locks, that means the transaction did not actually get processed, and then we'll come back and return false. But if I get all the way in here, I got both locks, I did the transfer, and all is well. So I come back to my program, and so hopefully this will run now because I built all three of my different transactions. I have this unreachable statement here. So I think there's going to be this part right here where I got this else where I didn't do something. Is that right? So if it didn't work, what do you mean that's unreachable? Oh, I got the exception at the bottom. I was going to say, it doesn't make any sense. All right, so I have this exception that I didn't comment out. Let's run the bank program again. What we're going to see here is that what happened is in my 100,000 transactions, let's say a dozen or so times on these 1,000 accounts, two of the transactions were between the same account, right? Or here was a deposit where maybe somebody was withdrawing at the same time or depositing something else in that account or doing a transfer between ID 501 and someone else, right? Here are some other ones that happened over the 100,000 transactions that I processed on all these guys. Now, what I will say is, one, this is, kind of nice, right? Like if you imagine a big bank, it's got an unending stream of transactions that are coming in. I just made a bunch up front. Like you'd imagine, like not only am I processing, at the same time, more transactions are coming in. So you could have tasks which were adding things in as people did these transactions. And so you're like, I just need to process all these transactions. I don't care about them being done in a specific order, maybe. Don't wait anything. Just throw them at the end of the queue or put them in to be dealt with later. What I will say is, so tryLock has its nice little feature. The other nice thing is that with this, you won't get deadlock in the situation where, you could have a cycle where the sender and the recipient, if anybody's ever had a situation where you've sent mail, like a lot of students use Venmo, and like imagine you have to pay your roommate for the rent while they're reimbursing you for groceries or something, and it happened at the same time. You could end up with some sort of deadlock situation. This tryLock, you never hold the locks unless you hold both of them, and so you'd be in good shape there. What I will say is there's a bonus situation where I don't think it would really come up in the sort of a bank situation where there would be this unending stream of things. You can imagine a situation where they were down to just like two transactions remained. They were both from sender to recipient. And you can imagine both of you picking up one of them and putting them down and always getting in this sort of loop. What you could do in that case is you could say like thread.sleep if it failed, right, just to protect yourself, like some thread local random.current, like just some random amount, right, some like 10 milliseconds or something where it was random, so that you could get yourself out of the situation where like some very strange case where like at the very end you would have something. Again, a bank with an unending stream of transactions is not going to end up in a situation where there are just two transactions left and they're from A to B and B to A and they were picking up and putting down and getting stuck. But this is sort of a strategy you can do just to prevent yourself from hitting that sort of situation. And so I thought I'd just mention that, and I've spent too much time on it already. It's sort of a rare case, but a way in which you can sort of just avoid getting into these strange situations, sort of sleeping around. Anyways, hopefully this has been helpful, and we will be using tryLock in this class soon.